welcome to LearnCity. My name is Praise and today we'll be solving examples on angle of depression, angle of elevation and bearing. And our first example today will be taking under angle of depression, where we have a boat is on the same horizontal level as the foot of a cliff and the angle of depression of the boat from the top of the cliff is 70 degrees. If the boat is 1 centimeter away from the foot of the cliff, find the height of the cliff to the nearest whole number. So we have the cliff to be this side when it's 1 centimeter away. This is the height and it comes down here. So we have this to be at 70 degrees. Here is also at 70 degrees. So this place is our hypotenuse. When you look up, so this is our diagram. So in this case, we have it to be tan, which is opposite over adjacent. So we have this to be our opposite and we have this to be our adjacent. Now we have tan 70 degrees to be h over 1 centimeters, where we have our h to be 120 tan 70. And we have tan 70 to be 1.221 and our h is now 146.52 meters. And where we round it up to the nearest whole number, we have it to h to be 147 meters. We have it to be 147 meters. So this is the height of the cliff. And our second example, which will be taken from angle of elevation, which says the diagram below represents a vertical inaccessible mountain XY standing on a horizontal ground ABX. If the angle of elevation of the top of the mountain from A and B are 30 and 70 degrees respectively, and AB is 500 meters, calculate correct to 3 significant figures BS and the height of the mountain. We have this diagram. We have here to be 70 degrees. We have here to be 30 degrees. Here we have X, Y, B, and A. So now, in triangle AXY, AX and Y, now where we said AB is 500 meter, here is 500 meter. So our first question is to find BX. So in this place, our AX will now be, let's represent this one as T. So we now have it to be 500 plus T meters. So now we have it to be tan 30 degrees to be h over 500 plus T meters. Now we cross multiply. We have h to be equals to tan 30 to bracket 500 plus T in meters, which is our equation 1. Now in triangle BXY, where we have this to be 70, this is B, this is X, and this is Y. We have this place to be T and this place to be H. So we have tan 70 to be H over T, where we cross multiply. We have our H to be tan 70 T, or we can say T tan 70. And this is our equation 2. So when we equate equation 1 and equation 2, we have 1 to be equals to 2, where we have t tan 70 to be equals to tan 30 into brackets 500 plus t all in meters. Now, when we equate both sides, so we have t tan 70 degrees to be 500 tan 30 degrees t dot, okay, we have this to be t dot tan 70 degrees to be 500 tan 30 degrees plus t tan 30 degrees. We have it to be t tan 30 degrees. Now, our t is also known as bx, where t is equals to bx. So we can have it to be bx tan 70 degrees equals to 500 tan 30 degrees plus bx tan 30 degrees. So now we collect like terms. We now have bx tan 70 degrees minus bx tan 30 degrees to now be 500 tan 30 degrees. And we have it to be bx into tan 70 degrees minus tan 30 degrees will equals to 500 tan 30 degrees. Then we divide through. Okay, before we divide, what is tan 70 and tan 30? We have tan 70 to be 2.747. So when we divide through by tan 70 minus tan 30. So we have it to be bx to now be equals to 500 tan 30 over tan 70 degrees minus tan 30 degrees. So we have this to be 500 times 0.5774 over 2.747. So when we multiply this, we have it to be 2887 over 2.170. And when we divide this, we have this to be 133.04, which gives us 133 meters. So our bx is now 133 meters. Our bx is 130. So to find the height of the mountain, from equation 2, here we have our h to be bx tan 30 degrees, and our bx is 133, which will be times 30. Here we have h equals to 133 times 2. We have bx tan 30 degrees. We have it to be bx tan 70 degrees. Sorry, this is tan 70 degrees. So we have 2.747, and our height here will give us 366.524. So we have our h to be 367 meters. We have our height to be 367 meters. And moving to the third example under bearing, our question says a plane flies 120 km on a bearing of 0.45 degrees. and then flies 150 kilometers due east. How far east of the starting point is the plane? How far east of the starting point is the plane? So where we have points here, at point 045 degrees, it traveled at 120 kilometers. So we have this 45 degrees. Now, due east, it traveled 150 kilometers. So from this point, it traveled 150 kilometers. Now, in which we have, now at this point to this point is now unknown, so we write as a kilometer. And it is important to know that the longest side is usually the hypotenuse. So that means A has to be longer than all the other one. So in this case, we'll be using our cosine rule. And where this is where we have 90 degrees. This is 90 degrees plus the 45 degrees. Then we have it to be 90 plus 45. We have it to be 135 degrees. So we have it to be 90 degrees plus 45 degrees to be 135 degrees. We have it to be 135 degrees. Now, using the cosine rule, here we have our a squared to be equals to b squared plus c squared minus 2b cos 2bc cos theta. So we have a squared to be equals to b squared plus c squared minus 2bc cos theta. So we have our cos theta to be 135 degrees. So our a squared will be, now b is 120, so we have 120 squared plus 150 squared minus 2 into bracket 120 times 150 cos 135 degrees. So we have our a squared to be 144 plus 22500 minus 36,000 cos 135 degrees. So we have our a squared to be 36,900 minus 36,000 times our cos 35 is minus 0.7071. So we have our a squared to be 36,900 plus, we have it to be 25455.84. We have it to be 25455.84. Here we have our a squared to be 62,355.84. So we find the square root. So we have our a to be 249.71 kilometers. So when we round it up, we have our a to be 250 kilometers. So the distance from the starting point of the plane is 250 kilometers to the nearest whole number. But we can easily say 249.7 kilometers. So our a is either of these two answers. So this brings us to the end of our class on angle of elevation, angle of depression, and the bearing, where we've done 3 different examples on these 3. So In our next class, we'll start a brand topic and we'll see you in the next class. Thank you.